When I open Mathcad Prime, the default view is the print preview. As you can see, the worksheet has a grid to assist with the alignment of content: text, mathematics, plots, tables, images, etc. When creating a Mathcad worksheet, I enter content into regions: text regions, mathematics regions, plot regions. Each of these types of regions has specific functionalities for processing or representing information for my project or task. Mathcad's Fluid Ribbon interface is organized to assist users in finding and implementing these functions. The Getting Started tab includes tutorials and help regarding Mathcad's tools. When exploring a ribbon, I can hover over buttons on the ribbon to bring up help information. Because Mathcad uses standard notation, trial and error using the ribbons is a productive way to learn how to use Mathcad Prime for specific applications. In today's webinar, I will focus on using Mathcad to create automated engineering worksheets. I will emphasize the use of the ribbon interface to create regions, define parameters and functions, and evaluate formulas, plot relationships, and ultimately create a reusable engineering worksheet that automates a problem-solving task. Using Mathcad's text and mathematics capabilities, it is possible to create reusable worksheets that illustrate and automate science and engineering principles required to solve problems. In a Mathcad worksheet, all of the regions float on the grid. Both math and text regions can be relocated by mouse selection and dragging. This is really helpful because when you're getting started with Mathcad, you might end up with a worksheet that looks like this initially as you work your way through the solution. But eventually, you want to produce something like this, and so you can actually go through and rearrange all the content. We'll demonstrate how to do that today. In order to be more efficient, it's helpful to think right from the start about how you might want to structure your worksheet. And that's what we'll focus on first. Mathcad Prime has a new type of region called a text block that's very helpful in structuring a worksheet. To demonstrate how text blocks work, I'm going to begin by inserting a new worksheet into Mathcad Prime. And then I'm going to locate the blue insertion cursor towards the top of my document and go up to the Math ribbon. On the Math ribbon, in the region types, I can find the text block, left-click on text block, and then I get a region that extends from margin to margin on my worksheet. I can relocate it up and down, but not from side to side. It's fixed to those margins. And I could go in and I can create, let's call it a title block, my worksheet title. I like to use text blocks at the beginning of a document and at the beginning of new sections in the document because they have some capabilities for providing structure that text boxes, as the alternative, do not offer. Once I've got my title in, I can begin to add additional content. And in this case, I'm going to add a text box, and I'm going to add it 2 rows down and 3 rows over from my text block. I'm on my worksheet. I've got my insertion cursor. I can insert any type of region, but I'm going to choose a text box. And when I do that, I can now have a space where I can type in input parameters and constants, often the things that begin the preparation of a worksheet. Here, this is wrapped around a little bit. I can resize the text box by dragging it over. That's one of the ways in which a text box and a text block are different. Mathcad has 3 different ways of inputting text boxes and other types of regions on a worksheet. One is to go up to the ribbon. Another is to use the hotkey, which you can see in the help box here, Control-T. The third way, and one that I actually prefer, is to right-click on a worksheet and open up the Worksheet menu and then insert a text box. So I can add a text box for data, and I can go here and I can right click and I can add another text box for calculations. And then to finish off my template, I can go down to the bottom. I can right click, insert a text block, and call that conclusions. So now I have a basic template that I can use to organize my document. These text boxes, if I want to relocate them, I can drag select them all and move them over to the right a little bit. If I want to slide everything up, I can select everything like that. I can use the up arrow to move that up one, and maybe I'll decide that I want to slide these back over to their initial position. If I hold down Control, I can click and select multiple regions, and then I can use the left arrow to slide them over as a group. So there, I'm pretty happy with that. I've got my basic template for creating a worksheet. Once I've got this template, Mathcad has nice capabilities for inserting some space. So if I'm ready to input my parameters, if I right click in here, I will pull up this menu again, and then I have different options: add space, add page break. Add space is just going to add a line, and that's the same as if I hit the return key or the enter key. If I backspace, it'll remove a line. I tend to use Add Page quite a bit. If I click on Add Page, everything slides down a whole page length of content. So now I have plenty of space to type in input parameters. And then when I'm done, I can go back and I can choose Remove Space, and it brings everything up and trims off the space right to the bottom of the content that I've introduced. So these are really handy ways of establishing a template and then working with it to create an engineering worksheet that others can use or that I can reuse over and over. Since engineering is a team sport, it is helpful to establish a standard template or format for presenting analyses and calculations. In this case, we're going to work from a very basic template, as you can see on the screen. I'm going to begin my calculation worksheet by defining input parameters and constants, so I'll click up in that section. And now I'm going to add some space. So I'm going to right click to pull up the worksheet menu. And I have three options: add space, add page, or add page break. I'm going to add page, so I'll left click on that, and that opens up a lot of space for me to begin typing input parameters and constants. In the example that we're going to use here, gravity is an active force. Newton's gravitational constant is actually a built-in constant in Mathcad. So in order to insert this information into the worksheet, I can just type G, the symbol that's used for Newton's constant, and then I can hit the equal sign for evaluation. And Mathcad will pull up the value that it has stored for that constant. It'll turn G green to show that this is a built-in unit, and it'll apply the units in blue, meters per second squared. Now I'm going to click below that because I want to define my first parameter. In order to insert a parameter, I'm going to go up to the operators menu and I'm going to do a definition. So I'm going to hover over the definition icon and see that colon is the hotkey, but I'll click on that icon and now I get a region where I can type the parameter name, which in this case will be mass 1, and then I'm going to go over and click on the right side. I could also have hit the right arrow key a couple of times, and I'm going to give this parameter a value of 3.5. I'm just typing in those numbers the way you normally would. And now I'm going to add a unit on, kilograms, which is abbreviated kg. So I'm just going to type kg. You'll notice that Mathcad inserts an implied multiplication sign. Kilograms is actually a mathematical unit here. And so now I have a mass 1 defined as 3.5 kilograms. And when I hit enter or click out of the region, the unit is recognized. And now I have both G and a mass. I'm going to insert one more parameter in this case, and this is going to be tension. So we're going to imagine that we're going to be lifting the mass. The mass in this case may be a ball with the hook on top where we can attach a rope and then we can apply a force. So the force is going to be called tension. And notice that when I just start typing tension, it shows up in italics. Default regions in Mathcad are math regions. So if I just start typing, I get a math region. So I can then go up and I can insert my definition operator, and then I can type 40 and a capital N and define a tension of 40 newtons. So now I have three different parameters, one constant and two variables, introduced in my worksheet, and I can use these in further calculations. Before I do that, I'm going to go ahead and remove the space. So I've right-clicked to pull up that menu, and I'll click Remove Space, and the rest of my regions come back, and now I'm good to go with my next section. So now as I look at my worksheet, it's beginning to get content, and I'm working within a structure. Now I probably want to add some context. I'll use this as a way to briefly review the insertion of text boxes. So I'm going to add text describing each of the parameters. So I can left click over here, and I'm going to go up to the math ribbon, and I'll insert a text box. And in this box I can describe this as Newton's gravitational constant. Okay, it's wrapped around a line a little bit, so I can extend that over, keep it on the same line. Now I'm going to right click next to mass 1, and I'm going to insert a text box and say that 3.5 kilograms is the mass of a ball. And I'll right click again here, insert another text box and say, is the tension applied to lift the ball? So I'm adding a little bit of context, telling my story, and at this point I might want to go up, click back in my text block and change the title. Maybe I'll click on formatting and change that to bold, but I'm going to type acceleration of the ball due to a vertical lift, and I probably want to spell things correctly. So I'll make that change, and now I've got a title and I've got the context added, and I'm going to move on with my worksheet. I'm going to assume that the ball is being lifted by a force applied vertically, and we're going to end up calculating the acceleration. So I have my problem set up, and now I'm going to go ahead with modeling the situation where we're going to assume that the ball is being lifted by applying a vertical force directly above the ball. So we're going to have tension in the rope, and that's going to apply the force. So the relationship between the upward acceleration of the ball and the tension in the rope can be written as an equation in Mathcad. And in order to do this, I'm going to move down to my calculation section, and I'm going to right-click there to pull up the In Worksheet menu, and I'm going to add a page. So now I have a lot of space again, and I'm going to insert an equation. Now we haven't inserted an equation yet. We've had definitions and evaluations. So I'm going to go over to the Math tab, and I'm going to click on Operators, and I'm going to go to Comparison, and I'm going to find the equal to icon. So equal to allows us to establish an equation to show that that one thing is the same as another. And so when I left click on that, I get a bold equal sign. And what we're going to do in this case, the situation is such that the tension minus the effect of gravity, so mass 1 times g, is going to be equivalent or the same as mass 1 times the acceleration of the ball moving upward. Now I have this equation, and when I look at it, it's easy to see that if I'm trying to find acceleration, acceleration must be equal to the left side of the equation divided by mass 1. So once I've made this statement of equality, I can now go ahead and define acceleration. So the acceleration is going to be tension minus mass 1 times g, and I could copy and paste this, but I want to demonstrate typing in. And now when I get to the end of the line, I want to divide that whole expression by mass 1, and so I'm going to click the spacebar once, twice, 3 times, and this performs what we call scoping. So now the next operation that I choose is going to be applied to this whole expression. So I'm going to go up to Operators, and I'm going to go over to Division, and I will select Division, and Mathcad expresses it as a fraction bar, and beneath that I can type mass 1. So now I have a definition of Excel, and I want to evaluate it. So I can type Excel, since it's now a value in my worksheet, and I can hit the equal sign, or I can choose the evaluation symbol from definition and evaluation. And the acceleration is calculated for me as 1.622 meters per second squared. And so what this is telling us is, given the current situation, the current values, the ball will be accelerating upward at 1.622 meters per second squared. So my worksheet currently looks like this, and I've used the input parameters to calculate the acceleration of the ball. 1.622 meters per second squared is the upward acceleration of the ball. And maybe now we want to take a look at that and see what effect that would have on the ball over time. We've assumed that the tension in the rope will remain a constant. So what exactly does this acceleration mean if we continue to apply it at the same level of force? So what we're going to do is we're going to create a function. And in Mathcad, function definitions are very similar to variable definitions. So let me move down here, and I'll scroll down with the mouse. I still have plenty of space. And we're going to insert a definition statement. So I'm going to go up to Operators and click Insert. And what we're going to do is we're going to create a function v for velocity and expressed as a function of time. So I'm going to type v left paren, and if I go up to the operators and I hover over left paren or the parentheses, you'll see that the left parenthesis is the hotkey, and that would insert a pair of parentheses in the worksheet. And I'm going to define a function v of t, and I'll click over on the right, and that's going to be equal to my acceleration times t. And if I want, I can go in and add a label here, insert a text box, and that's going to be telling us the velocity of the ball. Now once I have this defined, I can go in and evaluate this function. The function is based on t. Notice we haven't used t yet, but t is the way we've defined it here now, a parameter of this function. So essentially it's a local variable. And I can pass parameters 1 second, and then let's try 2 seconds. And notice that I'm just typing 2s, and Mathcad is recognizing seconds as the unit. And then I can just hit equals to evaluate, or go up and choose the evaluation, and I get the velocity after 2 seconds. And let's look at 3 seconds. I'll just type equals this time, and we can see that there's a pattern where the velocity continues to increase because we're applying a constant tension to the rope, and so that's leading the ball to go faster and faster as it's rising. So in looking at my worksheet, I can see that defined my parameters, I've defined a function, I've evaluated the function, and I've seen a pattern. Mathcad actually makes it very easy to look at this pattern in a graph as well. Plotting capabilities are very efficient. Let's click in the worksheet and scroll down a little bit, and let's add a new label. So I'm going to right click and I'm going to insert a text box, and I'm going to add a plot. And now I've got plenty of space down here for the plot, which is sometimes an issue. To add a plot to the worksheet, what I'm going to do is go up and choose the Plots tab. And when I get on the Plots tab, I'm going to go over to Insert Plot, and I'll left click on that, and it'll give me the 4 choices that we currently have. In this case, we want an XY plot. So I'm going to click XY plot, and it pops up there at the insertion point. This region here is for my dependent variable. It's labeled Y-axis. And if I click down here, this is x-axis, my independent variable. And what we want to do is we want to plot t along the x-axis for time. That was the parameter that we used. And up here, we want to type the name of the function, v left paren t. The parentheses here is, it says units above it. So units will appear when we make the plot. That's not a plot that we use to write the function. So now I have my plot defined, and if I click outside of the region, I get a line. Mathcad has chosen standard -10 to 10 along the x-axis. That determines the domain or the range on the y-axis. And when I look at my plot, I can see that the pattern is increasing linearly, which I would expect because I have a constant acceleration. Once I'm on the plot, maybe I'm not interested in this entire region. There are certain values that can be edited. The first and the second values on the x-axis can be edited if I want to go from 0, then 1, and maybe I want to finish at 3. I can come over here and do the maximum, and I'm just going to backspace to delete those, and it updates my plot automatically, and now I can see from 0 to 3 seconds what the apparent velocity is. But notice that I've got a little bit of a problem here. My velocity is being reported in acceleration units. Okay, and notice that t does not have units here. And so there's one more thing that I have to do if I really want to have a plot of velocity, and that's to give t some values. And there are 2 ways that we can do this in Mathcad. One would be to use a vector, and another would be to use what's called a range variable. And I'm going to use a range variable in this case because it's very similar to what we did with establishing the domain on the x-axis. So we need to do a definition. So I'm going to go back to the math, back to operators, and click on definition. And what we're going to define at this point is t. So we're going to give t specific values to pass to function v. And I'm going to go in and click in this region, and then I'm going to go to my operators, and I'm going to go down to matrix, and I'm going to choose a step range. And a step range is a way of giving a list of values to a variable name. So I'll select step range, and I get 3 placeholders. This is for the minimum, which I want to be 0 seconds. Then anytime I use units, I have to use it in all 3 places. So maybe we'll make our increment 1 second and our maximum 3 seconds. The second value establishes the increment throughout the list. Now when I click outside of that region, my plot updates. T now has units seconds, and the velocity now has units meters per second. And so I can see how the velocity changes over the course of t. And so I want to be very careful that I use these units because Mathcad has these capabilities. So as I look at my worksheet at this point, I can see I have calculated the constant acceleration, and I have a function that tells me the current velocity of the ball at time t. And I see that velocity on a plot. And it probably makes sense to wonder a little bit about, well, how does this affect the height of the ball? Maybe assuming that it's starting on a table or on the ground and it's being lifted. And Mathcad will enable us to quite easily go in and add the capability to calculate that height using a little bit of calculus, using an integral. So I'm going to click over here to create some space. I'll right click, and I'm going to go and I'm going to add a page to create enough space to go in and establish an integral to calculate the height. So the height at a certain point in time, if I want to take a definite integral, if I click on operators and click on integral, I want to use the velocity function v of t, and I want to integrate that with respect to time. And if I go from 0 seconds to 2 seconds, this should calculate the current height of the ball at 2 seconds. And if I were to change that to 1 second, it'll give me the height after 1 second, and so on. And so I'm able to calculate using a definite integral the current height of the ball. But I might also want to establish a function that will allow me to do this more generally. And so I'll go up and I'll create a definition, and now I'm going to define a function height of time, and I can use the integral in defining this as well. So I'm going to go to the operators and I'm going to choose the integral, and now I'm going to find the integral of v of t dt, and I'm going to go from 0 to t. And when I do that, I now have a function that will allow me to find the height at 2 seconds, and it gives me that same result, 3.244 meters. In addition, I could add that to my plot. So I'm going to click beneath that calculation now, and I'm going to remove space to pull my plot back up, and now my plot is kind of overlapping onto the next page. So maybe I'll go in and I will right click and I'll insert a page break. So I've moved my plot neatly down onto the next page, and I'm going to click here in the, my dependent variables region, and I want to add a new function. So I'll go up to the plots tab, and while I'm in here I can go up and I can add a trace to the y-axis, and the trace that I want to add is my new function h of t, and then when I do that I get line plot, right? So you can see it's showing that it's increasing like that. If I want to see what the curve looks like, I can change the increment on t just by going into the definition of my range variable here, t, change that to 0.1, and then I'll get a smoother curve because I have many more data points. And now we can see here's the velocity increasing, and here's the height of the ball increasing over time. And so I've actually managed to create, through a series of calculations and then derivations, functions that help me to explain the change in the height over time for this ball as it's lifted by the force that it's applied.